Hello, in this video let us discuss the schedules based on recoverability. The first type of schedule is a recoverable schedule. Let us consider this example schedule having two transactions. The first transaction has started its execution and has updated data item X. That has been taken by the second transaction. Assume that the second transaction has completed its execution and it is committed. After the second transaction is committed, now the control is switched from second transaction to the first transaction. Assume that while the first transaction is reading item Y, because of some internal error, the first transaction is failed. So the first transaction will be rolled back. The consequence of this is, though the second transaction is committed, still, since the second transaction has taken a value that has been updated by the first transaction, the second transaction should also be rolled back, or the modifications made by the second transaction should also be undone. The durability property of transaction says that a committed transaction should never be rolled back. To guarantee that property, recoverable schedule doesn't allow a transaction to get committed if it reads a data item that has been modified by some other transaction that is uncommitted. So in this case, the second transaction is not allowed to get committed until the first transaction is committed. The second transaction, though the execution of second transaction is over, it has to wait until the first transaction has been committed, since it has taken the value that has been modified by the first transaction. Such schedules are called recoverable schedules. The second type of schedule is a cascadeless schedule. Let us consider a schedule consisting of three transactions T1, T2 and T3. So consider the scenario that the first transaction is reading data item X and it is writing the same data item X that has been taken by the second transaction, and the second transaction is also modifying the same data item X. After that, the third transaction is also modifying the data item X. Now, the third transaction should wait until the second transaction gets committed according to the recoverable schedule, and second transaction should wait until the first transaction gets committed. Now let us assume the situation that the first transaction is failed and it is aborted, and this will cause the second transaction to get rolled back, and which will in turn cause the third transaction to get rolled back. So this is creating a cascading of rollbacks. The transaction execution is very expensive in terms of time complexity. Though a successful transaction has finished its execution, since it has taken a value that is written by an uncommitted transaction, the transaction is to be rolled back. So this cascading of rollbacks can be avoided by using a cascadeless schedule. While using a cascadeless schedule, a transaction is not allowed to read a data item that has been modified by uncommitted transaction. So if you look at the second schedule S2, so the second schedule allows the second transaction to read a data item X only after the first transaction is committed. Similarly, the third transaction is allowed to read the data item X from second transaction only after the second transaction is committed. So this avoids, cascadeless schedule avoids cascading rollbacks. The third type of schedule is a strict schedule. A cascadeless schedule doesn't allow a transaction to read a data item that has been modified by uncommitted transaction, but a transaction is allowed to write a data item that has been modified by uncommitted transaction. But a strict schedule doesn't allow a transaction either to read or to write a data item that has been modified by uncommitted transaction. Thank you for watching this video. If you have any queries, you can contact me. My mail ID is achaprala@gmail.com.